Now look at this situation. So derive the general equation of circle. Okay, while dealing with straight line, you guys have studied the general form of like 2-degree curve, the condition at which 2-degree curve will represent a straight line. We guys have already studied. Okay, now we have to understand under what conditions that 2-degree curve will represent circle, and there is a situation also when that 2-degree curve will represent parabola, ellipse and hyperbola. We will study later. like for time being, just recall that situation. So it was x square, then y square, xy plus x plus y plus equals to 0. Okay, and then we wrote a b c f g h, and then this 2 2 2. Okay, so this was the general equation of 2-degree curve. Okay, right now we are interested in finding the situation where this 2-degree curve will represent a circle. Okay, so in general we have already derived x minus alpha whole square plus y minus beta whole square is equal to r square, and here you know that center of a circle is alpha comma beta and radius is r. So we will take help of this situation as well. Okay, like right now we don't know anything, so can we open this bracket and we will have a square plus b square minus 2ab. Similarly, a square plus b square minus 2ab minus r square equals to 0. Okay, wait a second. Okay, now look at this. Now let's rearrange things. Means I want to write x square first and then y square and then xy. We don't have xy. Okay, then we will write x. So it is minus 2 alpha x, then y minus 2 beta y, and then those constants are alpha square plus beta square minus radius square. Okay, now look at this. You can compare this equation with this equation. You can conclude that, sir, here a is equal to b is equal to 1. So here a and b should be 1, and also you got x and y component over here, but there xy component is missing. So can I say that along with this h should be 0? Okay, so this is the condition for a 2-degree curve to represent a circle. Condition for 2-degree curve to represent represent a circle. Okay, now let's try to figure out what is the center. Okay, you know that the center was alpha comma beta, and you have alpha over here and beta over here. Okay, so can I write minus of 2 alpha? We have to compare coefficient of x. So here coefficient of x is minus 2 alpha and here coefficient of x is 2g. Okay, so it is 2g, and coefficient of y minus 2 beta, and coefficient of y is 2f. So this two got neutralized, this two got neutralized. So earlier our center was alpha comma beta. Now it got updated and it become minus g comma minus f. Okay, so to find out the center of a circle, okay, what you have to do, you have to focus on coefficient of x and coefficient of y. So what we have to do, just divide coefficient of x by 2 and multiply with minus sign. Just divide coefficient of y with 2 and multiply with negative sign. You will get your center. Is that clear? Now for radius we will compare the constant. So here constant is c and here constant is alpha square plus beta square minus radius square. So you know that radius is r square, so we can compare. So alpha square plus beta square minus radius square is equal to c. So radius would be what? Radius, this r square this side and then this c this side. So can I write alpha square plus beta square minus c, all thing under root? Okay, you also know that alpha is minus g, beta is minus f. So can I write radius as root over g square plus f square minus c to get the length of radius? Is that clear? Okay, so I am concluding again. So for center you have to divide coefficient of x by 2 and then multiply by minus sign. For this is x coordinate of the center, and for y coordinate of the center you have to divide coefficient of y with 2 and then multiply by negative sign. And for radius you got root over g square plus f square minus c. Is that clear?